Welcome. This is Eureka Math, Module 4, Lesson 32. My name is Mr. Shankel. I'll be taking you through Lesson 32, where we talk about multi-step problems in the real world. In the opening exercise, we have a situation. Let's read what we have. Zin is buying beverages for a party that come in packs of 8. Let P be the number of packages Zin buys, and T be the total number of beverages. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine the independent and the dependent variables in this scenario, and then make a table using whole number values of P less than 6. All right, well, a lot of this has been done for us, and even if you understand the tables, like we talked about in Lesson 21, you can even see the independent and dependent variables based on where they are in the table. But we'll talk about independent and dependent again so you can understand what those are. The independent variable is the variable that you can choose. So based on the situation, what is it that you can choose in this scenario? Can you choose the number of packages that Zin buys, or do you get to choose the total number of beverages that he gets? Well, what we really get to choose is how many we buy. You can buy none, or 1, or 2, or 3, or 50. That's your choice. So that is the independent variable. So we would say that the independent variable is the number of packages that Zin is buying. The dependent variable depends on your choice in the independent variable side. So if we choose 0 packages, then Zin gets 0 beverages. If we choose to buy 1 package, then Zin gets 8 times 1, or 8 beverages. So the number of beverages depends on how many Zin buys, how many packages he buys. So we talk about depends and determines. So you can really kind of talk your way through this and figure it out. The number of packages determines how many beverages we get. So we could think of it that way. The number of packages determines how many beverages we get. And then on the other direction, we could say the number of beverages that we get depends on how many packages you buy. The number of packages you buy determines how many beverages you get, and the number of beverages that you have depends on how many packages you buy. It doesn't work if you turn it around the other direction. So let me show you what I mean. If we took this arrow away and that arrow away, and we turned it around, so now we're saying the number of beverages that I have determines how many packages I buy, and then the number of packages that I buy depends on how many beverages I have. Well, that just doesn't make sense. So if you read it and in this fashion, determines and depends, and it doesn't make sense, well, then you probably have it the wrong way. So turn it around the other way and see if it makes sense that way. So if we take the arrows away again and we turn it around and we go the other way, the number of packages I buy determines how many drinks I have. That sounds right. Or the number of beverages that I have depends on how many packages I buy. Those both make sense, so we have it the right way. The number of beverages is dependent on the number of packages. Okay, so independent and dependent. Oops, I wanted to get rid of this, not the other stuff. So we have an independent variable here. That's the one I get to choose. And we have a dependent variable here. That is the one that depends on my choice. Okay? What we're doing to find the number is we're just substituting a number for p into our equation. So t equals 8 times p, and in this case, p is 2. So 8 times 2 is 16. 3 goes in, and now 8 times 3, 24. When the number of packages is 4, 8 times 4 is 32 beverages. Put a 5 in, and we get 40 beverages. So we can continue to make the table by plugging in a number for p, substituting that number, and calculating by multiplying in this case. Okay, I said that you could also tell which one's the independent and which one's the dependent variable just by where it is in the columns in the table. Your first column should always be the independent variable. Second column is always the dependent variable. If we thought of this as a x and a y ordered pair, the x goes first, that's independent. The y goes second, that's dependent. So whenever you get to algebra with line equations, the x value is your independent variable and the y value is your dependent variable. Okay, let's move on. Our next thing is to make a graph for that table. And when we make the graph, the independent variable has to go on the x-axis. So the independent variable goes here, and that independent variable is the number of packages. So I need to say number of packages. Okay, we've got to have that label for our x-axis. The dependent variable always goes on the y-axis. So the dependent variable is going to go here, and that dependent variable is number of beverages. So we got to say that, number of beverages. Okay, and we're going to go anywhere from 0 packages to all the way up to, we'll go to 5. 0 packages all the way up to 5. And then we, remember every package that we buy, we got 8 beverages. So 8, 16, 24 would go here, 32, and 40 would go there. All right, and then we also need a title. So maybe this is party, or party purchases, or party drinks, or party beverages, or something. We're going to name it something that has to do with the situation, and then we plot it. So let me get you a new color so we can see where these go. If I buy 1 package, I get 8 beverages. If I buy 2 packages, I get 16. If I buy 3, I get 24. If I buy 4, I get 32. And if I buy 5, I get 40. So there's our graph. And the last thing is, do we draw a line? Well, you ask yourself, can I buy a portion of a package? Can I buy any fraction of a package? And the answer is no. You either buy a package or you don't. Can't buy a half a package or a third of a package. So we can't. So we do not draw a line on this graph. All right, next. Example 2. Use the graph to determine which variable is the independent variable and which is the dependent variable. Well, remember, our independent variable has to go on the x-axis. So I know the number of hours is independent. That's the one I get to choose. Okay? That means that the dependent variable is on the y-axis. So the number of miles is dependent. And we can check it. Do the number of miles depend on how many hours I drive? Well, sure. I could drive 0 hours and I go 0 miles. I could drive 5 hours and I go 250 miles in this case. 5 hours matches to 250 miles. So the number of miles depends on how many hours I drive, and the number of hours I drive determines how many miles I go. So that is correct. You can always think it through like that, determines, depends, or you can know what a graph is supposed to look like. The x-axis always is independent, so here, and the y-axis is always dependent. All right, now it's your turn. Let's go to exercise 1. Please pause the video, and I want you to try this. I want you to see if you can make yourself a table with the independent and the dependent variable in the correct spot, and then create yourself a graph. And when you've finished up, start the video again. I'll show you how to solve it correctly. All right, so we are back. We're going to put this table and graph together. Each week, Quentin earns $30. If he saves this money, create a graph that shows the total amount of money Quentin has saved from week 1 through week 8. Write an equation that represents the relationship between the number of weeks that Quentin has saved his money, and we'll call that W, and the total amount of money in dollars that he has saved, and we'll call that S. Then name the independent and the dependent variables, and write a sentence to show this relationship. We'll talk about that. And then we're going to also make a graph. All right, so here we go. We have two variables, W and S. We have to determine which one is independent and dependent. So let's do that first. So the number of weeks that Quentin has saved his money is W. All right, now I'm going to start thinking, do I get to choose that? Do I get to choose how many weeks that Quentin saves? Does Quentin get to choose how many weeks that he saves? Kind of sounds like he does, right? He could save for no weeks, or he could save for 20 weeks. It's his choice. So I'm thinking that's independent, but let's see what the other one is. The other one is the total amount of money that he has saved, and that's going to be S. So does he get to choose the total amount of money he saved? Well, kind of, but doesn't the amount of money that he has saved depend on how long he's been saving? I think it does. Does the number of weeks that he saves determine how much money he has? Yeah, I think he does. So W is going to be our independent variable, and that's going to go in the first column. S is the dependent variable, and that's going to go in the second column. Okay, so if Quentin saves for 1 week, how much money does he have? Well, it says that he earns $30 every week, and he's saving it. So after 1 week, he has $30. 2 weeks, $60. 3 weeks, $90. 4, $120. 5, $150. 6, $180. 7, $210. And 8 is $240. Okay, then we have to write an equation, and the equation is when the number of weeks that he saved is W weeks, which means we don't know any amount of weeks. What is S? Well, we have to multiply by 30, so it's 30W. So the amount of money that he saves is equal to 30 times the number of weeks that he saves. All right? Now, to make the graph, let me switch colors here. How about purple? W will go in the x-axis. So W is the number of weeks that he's saved. That's going to go on the x-axis. And the dependent variable goes on the y-axis. So that is the amount of money that he saved. So total dollars saved. Okay, so we label that. Total dollars saved. And then, I don't know, we can go 2, 4, 6, 8 maybe to fit it all on there. All right, because I can't do 1, 2, 3, 4, 5. There's not going to be enough room. So I'm going to count by twos. And I know that the 1 is in between there, right? 1, there's 3, there's 5, there's 7. So we can fit all of our data on there still. And we're going to go from $30 all the way up to $240. So if I go by 50, this would be 50, 100, 150, 200, 250, and that's going to fit. So that'll work out nice. Okay, so we'll make our interval 50s there. And then we just plot the data. 1 week saved, he's going to have $30. So about right there. After 2 weeks, $60, a little bit more than 50. Okay, after 3 weeks, it's 90, just under 100. After 4 weeks, it's 120. So that's somewhere right in there. After 5 weeks, it's 150. That's right on the line. After 6 weeks, we'll be at 180, a little less than 200, so right in that area. After 7 weeks, it's 210, a little bit above 200, and then 8 is 240. So 8 will be, let me get that down out of there, 240, just under 250, so right in there. All right, and then the question is, could we save, we got to figure out, do we need a line here? Could we save for a fraction of a week? Well, yes. If he gets paid every day, we could definitely see some other data points. If he gets paid, by the minute, then obviously we would get other data points. So yeah, I think we can draw a line here because we are going to have data points between 0 and 1. He could work for 15 minutes and he would earn some amount of money. So we do need a line on this one. And it's just going to continue in that fashion. All right. What's our title? I don't know. Maybe savings. Something like that. Savings. Okay. Let's try another one. Pause it. Try it yourself. And then we'll come back and see if you can get the right answers. All right, exercise 2. Zoe is collecting books to donate. She started with 3 books and collects 2 more each week. She's been using the equation B equals 2W plus 3, where B is the total number of books that she's collected, and W is the number of weeks that she's been collecting those books. We're going to name the independent and the dependent variables, and then we're going to create a graph to represent how many books Zoe has collected when W is 5 or less. All right, so we've got a couple of variables. We have B, which is the total number of books, and we have W, which is the total number of weeks. So which one is the independent variable? Well, if you look at your equation, the independent variable is always that one, the one with the coefficient. Or if we think about it, the total number of books depends on how many weeks she collects them. If she collects them for 0 weeks, she has less books. If she collects for 100 weeks, she has a lot more books. So the number of books is dependent on the number of weeks. That means W is independent and B is dependent. Should be like that. All right, we're going to go collecting for less than 5. So let's put a 0 in there. If she collects for 0 weeks, she's going to have some books. 1, 2, 3, 4, and 5. And now let's figure this out. If she collects for 0 weeks, I just plug it into my equation. I put that 0 in for W. So 2 times 0 is 0, plus 3 is 3. If she collects for 0 weeks, she has 3 books. And remember, she had 3 books to start with. Okay. If she collects for 1 week, that's 1 times 2 is 2, plus 3 is 5. If she collects for 2 weeks, 2 times 2 is 4, plus 3 is 7. If she collects for 3 weeks, 2 times 3 is 6, plus 3 is 9. And you can see now that we're going up by 2 every time. So this is an 11. This is a 13. All right. The independent variable W, which is the number of weeks, goes on the x-axis. So number of weeks goes here. And the dependent variable is the total number of books. So total number of books goes on the y-axis. So it has to be that way. And then we graph our points. Looks like I can go 0, 1, 2, 3, 4, and 5 will fit on there nicely. And then we go from 3 to 13. So I think we can we fit them all on there? Looks like it. 3, 5, 7, 9, 11, and 13 at the top. And when we graph those points, we get, after 0 weeks, 3. Oops, sorry about that. After 0 weeks, 3 books. After 1 week, 5 books. After 2, we have 7. After 3, we have 9. After 4, 11. And after 5, 13. And then we have to decide, is there going to be an arrow? Well, can you collect for a fraction of a week? Yes. But can I get fractions of books? Well, no. I can either get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So we cannot draw an arrow here. Those have to be dotted, just the dots. All right. I think one more on this lesson. Let's pause the video and try to solve exercise 3. All right, we're back. Exercise 3 is the same thing. We're going to determine which one's independent and dependent, make ourselves a table, make ourselves a graph. So here's the problem. Elena plans to visit the fair. She must pay $5 to enter the fairgrounds and an additional $3 per ride. Write an equation to show the relationship between R, the number of rides, and T, the total cost in dollars. State which variable is dependent and independent, and then create a graph. So I like to start with the dependent and independent because that tells us which column that we put those variables in our table. So does the number of rides depend on the total cost, or does the total cost depend on the number of rides we choose? I would say the latter. We get to choose the number of rides we go on. That's independent. So R goes in the independent variable side, the first column. The total cost depends on how many rides we choose. So that's dependent. R in the first column, T in the second column. R is independent, T is dependent. And if you think of it the other way, R determines our total cost. T depends on the total number of rides that we choose. All right, so there we have it. We need to say, hey, what if we go on 0 rides? Well, if we go on 0 rides, it's going to cost us nothing per ride, so we're not going to pay the $3 per ride, this part. We're not going to pay that because we didn't go on any rides. But we still have to enter the fairgrounds, so it's going to cost us $5. Okay, $5. If we ride 1 ride, well, now we're going to pay the $3, and we got to get in, so that's $8. If we ride 2 rides, well, then it's 2 times 3, that's 6, plus 5, 11. 3 rides, 3 times 3 is 9, plus 5, 14. 3 rides is $14. If we go on 4 rides, 4 times 3 is 12, plus 5, 17. What if we go on R rides? Well, remember we talked about a way that you can write the equation either based on the story or based on the table. So let's do the table way this time. If our independent variable changes by 1, then our dependent variable change is our coefficient. So that is the coefficient, and it stays a plus 3 every time we go down, so we know it's not an exponent. So I know right away that it's 3R. That's the beginning of our equation. 3R. Well, if I put a 0 in for R, 3 times 0 is 0. What would I have to add to make it 5? Well, I'd have to add 5. So that's my equation. T is equal to 3 times R plus 5. And we can test it by putting a 1 in for R. So 3 times 1 is 3, plus 5 is 8. It's supposed to be 8. Put a 2 in. 3 times 2 is 6, plus 5 is 11. It's supposed to be 11. So this equation is going to work for us. That's our equation. Okay, last thing's the table. Independent variable goes on the x-axis. So the independent variable is the number of rides. The dependent variable is the total cost, and that goes on the y-axis. So total cost, total dollars, goes on the y-axis. If we ride 0 rides, 1 ride, 2 rides, 3 rides, 4 rides, 5 rides, we can keep that going if we want. We're going to go all the way up to 17, so it looks like they will fit. So we've got $5, and then 8, and then 11, and then 14, and then 17, and we can even go another 3, and that's going to be $20. Okay, and then we plot them. If we ride 0 rides, costs $5. Let me get a different color. Okay, if we ride 0 rides, it's $5. 1 ride is $8. 2 rides is $11. 3 is $14. 4 is $17. 5 is $20. Can we ride a fraction of a ride? Nope. So there's no arrow, and maybe this is the fare. That's our title. Okay. Hope that helped you out today. Your job is to complete the problem set for your practice. Talk to you again next time.